All right. So today we are here just talking about multi-agent solutions in Copilot. So we're going to consider how like two different platforms, Copilot Studio and versus Agents Toolkit. Those feature itself only became available last year. For Copilot Studio was around Build, and for Agents Toolkit it was around Ignite. So both very fairly new, and we'll bring it to life as we proceed with our. Oh, fine. Okay, so this is the code.com deck, which already been gone through at the beginning of the conference, so I'm just gonna skip it. A little bit about me. So I'm Reshmee Auckloo. I'm currently working as consultant at Avanade. I do a fair bit of blogging, and I'm maintainer of PNP PowerShell as well. So if ever you use PNP PowerShell, so I'm one of those, of the team maintaining it. And yeah, I love SharePoint and M365. So I'm joined today by Lee.
Yeah, I don't love SharePoint. Yeah, I'm a developer. I work M365 mainly Copilot and Teams and things like that. And yes, similar to Reshmee, like to write code and maintain scripts and samples and things like that. So I think this is my slide. It takes a little while to work out who's doing what. So this is the agenda for this session. So we're going to go through, before we go into sort of the multi-agent architecture, we're going to start with just sort of setting a baseline of what we're talking about when we're mentioning agents. We'll do a quick overview of the two tools that we're talking about. There are other options, but these are the two that we're focusing on our session. And then we'll get more into multi-agent architecture, what we mean by that, and how we can build that in both applications. And then there will be some demos as well. Hopefully, we've sacrificed to the demo gods enough that they will work for us. So when it comes to what an agent is, this is Microsoft's definition from a graphical point of view. We have the foundational models at the bottom, so that's your GPT, that's your Claude, and then we have on the left the orchestrator. So that's the brains, really. That's the bit that knows when to call which tool, when to call an API. If you've got connected agents or other agents, which is obviously what we're talking about today, multi-agents. That's when to bring those agents into the conversation, when to not to use them. And then at the top we've got the user experience. So in this case, it's obviously Copilot is the user interface, but obviously it could be other sort of surface areas as well. So as I said, we're talking about Copilot Studio and Agents Toolkit, and the sort of the three highlighted areas here is really what we're focusing on. So we're not really working on the M365 Copilot agents that you'd build in something like Agent Builder. Instead, we're looking at the sort of more sort of complex agents, I guess. So if we start from a Copilot Studio point of view, obviously that's more low code. It's sort of more aimed at makers, and then moving over to Agents Toolkit, that's more it can be pretty much code exclusively, or it can be a mixture of sort of low code and pro code. There are some key differences, things like orchestrators. So the orchestrator in Copilot Studio is different to the orchestrator in a declarative agent or an orchestrator that you end up using in your own custom engine agent, and similarly with things like foundational models and knowledge sources and capabilities, and there is sort of key differences between them. Some of those we will cover as it makes sense to when we're talking about multi-agents. Some of it is just how they are fundamentally different. I think the key point really here is from a cost perspective, there is a difference. When you're building something in Copilot Studio, you're either using a consumption credits basis, or you're obviously uses a license to be able to use the agent, or to be able to publish an agent. With declarative agents is a little bit different. Certain parts of it you can just use for quote unquote free. Other parts you will need to be a licensed user to make full use of that agent. And when it comes to custom engine agents, effectively, because you're just exposing the sort of the agent via Copilot, none of it's actually running within Microsoft's world as such, or it doesn't have to. There is no license for that.
Well, the Copilot Studio. So this platform is great, like for makers, for the low-code power users. It's quicker, like to get started. And as Renato mentioned, like in his presentation, it comes up with a load of uh, existing tools you can connect to, like the NCP, prompt, agent flows, connectors. It's really a powerful platform where you can easily like spin up agent. And one of the thing, yeah, it kind of comes like with the enterprise security and governance being like on the Microsoft platform. And then the other one is the M365 Agent Toolkit. It doesn't get as much love as Copilot Studio, but it's still very powerful. And it's kind of excluded a lot, like from the marketing, from the slides, where it talks a lot about Copilot Studio and straight into Foundry, but that one is not being talked that much. So hopefully at the end of the session, you will find like another great way where you can extend M365 Copilot using the M365 Agents Toolkit. I know Microsoft didn't make it easy having like different variations of like AI Toolkit or Agents 365 Toolkit or like to get confused with all those terminology. But this one is an extension in Visual Code, so we'll go through later, like through the demos, how it's all how we all bring it to life. Um, Using like the Emphasize Agents Toolkit, you can use it to build declarative agents. That means it's used like the M365 Copilot, like the Sydney orchestrator I showed by Lee, or we can have like a custom engine agent where you bring your own AI model, like using leveraging like Microsoft Foundry, and then you can like orchestrate like all the different agents, like using LangChain or the agent for SDK. But I think today we are using LangChain to show how it's all come together. Now let's come to the main topic of our session, multi-agent architecture. So why do we need to build multiple agents? If you think of the software engineering principle around converting monolithic solutions into microservices, it's kind of follow the same analogy. So instead of having one particular agent which does everything in your organizations, maybe HR, finance, marketing, or sales, it's not going to scale very well because having too much knowledge sources, tools, may struggle to provide the correct answer. It's better to build what we call like domain or domain specific agent restricting to particular knowledge sources, tools, so that it can reason better. And the other idea is around like the modularity and reusability. Say if you have like a simple piece of function which could easily like be reused across multiple agents. Let's say, for example, in your organization, if everyone has to fill timesheet, for example, maybe you have a timesheet agent which sits separately, but you want it to be tied up to other different agents. Let's say for the IT support desk, you want them to access that timesheet agents to be able to do the timesheet, but as well as grounded with the IT support context, depending on what they're doing. And the other thing is around testing and maintainability. So if I update one of the agent, let's say the timesheet agent I mentioned, so I can update it in uh, one location, and then that changes would propagate across all the different agents, which is going to use it. And the other one is like if you build like an agent Copilot Studio, you have like the 8,000 instruction limit. But to be honest, like from my own experience, if you have like the instructions too big, even if it doesn't exceed 8K, I can't get it like to use to reason over all like the long instructions. So it's better to kind of break it. But in case you have like a lot of instructions, if you go for multi-agents, you kind of divide those instructions like in different agents, so you can make it a little bit more specific, and as well you can combine together. It could be more than the 8,000 instructions limit. Yeah. So in Copilot Studio provide different ways you can have like the multi-agent scenarios, which is quite good. Like and then it's something that we have to be conscious whether how we're building those agents. Because if you create a connected agent, which is a standalone agent, um, it creates like loads of artifacts within your environment, which you need to be aware. Like it could lead like to agents role probably, which you don't want to, and maybe more difficult like to govern. And in that case, probably you might think like which one is more suited, a child agent or versus a connected agent. We'll cover it a little bit later in the slide, like some of the decision framework that you may questions that you may ask yourself before deciding which one to go with. The other one is, as Renato showed in his previous demo, connecting to a Fabric agent. Of course, the cross-platform connection that you can connect like to Microsoft Foundry agent or the M365 Agent SDK. And the orchestrator agent is the parent or agent, which is going to route or decide like how to make all the agents collaborate together. Yeah, so this is like something that you need to be aware, like when to go for a child agent or connected agent. So you think of a child agent as a lightweight agent which lives with a parent agent. It shares like the same knowledge and tools, and it has like the same settings. But one of the drawbacks that it can't be used outside the parent agent. And one of the good use case scenario could be, let's say, if you have like IT support agent, and you might want to, because it's used by the team, but you might have like different knowledge sources and different tools, like to be able to do different tasks. So you can have like sub agents which kind of specialize and help like with a different tasks or processes for the IT support team. And connected agent, it could be like it's it's owned like by different teams, and it might already have existed, and you just want like to plug in to different agents. For example, you can have like an expenses agent, which is needs to be available for everyone, but it's being built by the finance team, so they've maintained like how it's the process, and if it's changed, so the finance team will be responsible of managing that particular one. And the other one, it could be like you want like to change to use a different model, maybe like again for finance, maybe you want like something which is more accurate, so you might want to go for a more expensive model. And if you have like another agent which probably doesn't need to be that accurate, and you're happy like with a less expensive model. So there are kind of different reasons why you would go for a connected agent. But yeah, child agent is very good options, like again, like to help like with the agent's role, and just to keep it easy to manage in the long run as well. So I have like a particular scenario which I built. This is like an insurance claims and code agent. This will allow the end user to submit like an insurance claim, and as well as request an insurance code agent. So what I have colored in red, we have the child agents, and colored in blue, they are like the connected independent agent. So I'm thinking, like, for example, for a code agent, maybe I want it to be for it like to be um, publicly available, like on a particular website. So anyone, like without any authentication, can go and ask for insurance code. And then but the other way is like for claims agents, you want the users to be authenticated so that you can do the trade checks before we actually submit an insurance claim. So that's my reasoning model why for the insurance code agent is like a connected, like independent agent. And then for the insurance claims agent, I have many um, child agents, which I'm going to showcase and explain why I've done it that way. And then I have like another one, which I'm calling orchestra agent, but doesn't really need to be, but it's just like connecting just the independent insurance code agent and the reports agent. Again, I'll show in the demo, but then you might be thinking why I didn't connect it directly to the claims and code agent. I did do that, but I don't know whether it's a limitation. But when I checked it like last week, it doesn't seem to reason well if I connected to a connected agent, which has both the child agent and a connected agent. But I don't know whether it's something, it's a no limitation or whether it's something like will be fixed at some point. Anyway, that's it, and I'll just move on to the demo. Right, so now I have the independent agent, which is called the insurance code agent. Yeah, what I've done, it's for a fictitious company providing different type of insurance like car, health, travel, could be a lot more. And then with similar case scenario, I have, oh, I hate when I share, I can't really see. Wait, oh, and I have, okay, I'll click again on the same one. That's all right. Ah, can't really see. That's incredible. Right. So this one I have okay, that's better. Okay, so I have two of them. I'm going to show you. One is the independent code agents where I have different topics and and then here I have what we call child agent and the one connected agent, which is the insurance code agent, which has different topic. So one of the thing I wanted to do was for this one also, I wanted it to be child agent instead of topic, but because for insurance code, I'm using topic, it's more like a deterministic conversation flow. So each time the topic gets triggered, it will go like through the same steps, which I've defined in my topic. Like here, I'm requesting like information from the end user, which is going to enable me to calculate the insurance premium and then do a lot. I'm only doing like one particular validation to ensure like the user is more than 18 years old. This is a demo, but we could add more validation around 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 the input which the user provide, but I'm not in that scenario. And one other thing, I'm setting like different variables and and the other thing is calculating the insurance premium. Bear in mind, this is completely fictitious, so it's not like have any bearing on the real insurance calculations because it could be more complex, involving machine learning to be able like to predict like an insurance code. But this one is just quite static. I have a static formula. So I want like insurance code needs to be quite accurate, like in in terms of the the premiums that it's providing, or having some kind of logic that it is using to calculate those. But then if I look at my insurance claims and policy code agent, I'm just going to go for one, which is a car insurance agent. Here I have like the same concept, but expressed in terms of natural language, where I'm saying like step 1, step 2, step 3, what to do to provide details at different step of the process, as well as calling like what we call like agent flows to retrieve details for the particular user. And one of the things that was mentioned, the limitation, which I did find it, like even if you use a child agent, you can't really, if you do like the slash forward, you can't really reference like a particular knowledge source. And I think AG showed like a workaround where you can kind of hard code, like providing like the exact knowledge source name, like to know how it's risen. But sometimes it just doesn't work. So one of the reasons why you might want to use like a child agent is around routing. Yeah, I didn't make any changes. It's around routing of the knowledge sources. So in here, I have 3 files which are stored in a SharePoint site, and all those files, they are insurance policies again. But this one I've downloaded it, but they're publicly available, like from insurance companies. So they are real insurance policy. But again, it's publicly available. It's fine. So it's easier like to use in my case. But then if you look at those knowledge source, each ones are available only to a specific child agent. They have the car insurance agent being triggered, it will use information only from the car insurance. The same for the dental insurance, if it's going to use the information from the dental insurance. Yeah. So, and the other thing about the actual parent agent, if you look at the instruction, it doesn't have anything. This one could have been the description, to be honest. It doesn't have like anything. It's just very, very short. So, and all the intelligence is baked in the child agent. The one of the benefits of doing that, because each time the parent agent gets triggered, the instruction that he has to go through, it's it's like nothing. So it might be faster, like to start up with, and once it knows like which agents that it's going to trigger, it will use like the tools and the knowledge and the instructions on each of the individual child agent. So here I have like the instructions, which I've already showed you down. Yeah, so one the other reason, yeah, I've kind of forgetting. Yeah, so one is you can't easily like reference like the knowledge source for that particular agent. You can't set it up, and the other one is around like setting up variables, because I have a lot of variables I'm setting, which I need like to use in a Power FX, where I can include a Power FX here. But then it's like the ability of setting all those variables in a quite deterministic way. That's another reason why I kind of just kept it like as topic, and for the other agent and this one as child agent. Yeah, so 3 benefits I can say of using the child agent. Routing of knowledge sources. Second is about your parent agent itself, instruction, keep it short so that it's a little bit faster and more accurate. And yeah, and the other one, it's more like it's lightweight. It's like within the parent agent sharing all like the settings. Yeah. So let's go into the demo. So let's see if my demo works, because I did have some issues previous, like in the morning, even before trying to get it to work, mainly because I don't know whether something changed with the platform, but it's just taking a little bit longer to come back with an answer. So I can see, yeah, possibly it's not going to work because it's supposed like to ask me for email address. Okay, I'll just go through another one which I've done earlier. Um, okay, so this is the same one which I was trying to repeat, but it was supposed like to prompt me like for email address, which it kind of didn't do. And then in the example, I say I want to make a claim for MOT cost for my car. MOT is similar to per person. It could be like a health check, but this is a health check for a car. And normally insurance companies don't cover MOT costs for my car. And what it did in the background, it's like retrieve the details for that particular user, and check whether there are any active insurance policy for that particular user. And as well in the instructions, I did include ask it like to make sure that whatever the user is requesting, whether it's actually covered in the insurance policy. So in that particular scenario, the MOT is not covered. It's like the health check, but then I kind of gave it like a different alternative query. And then I provided all the details like about the incident date, when it happened, and then it kind of created the claim, which it kind of saved it in a SharePoint library this time. So yeah, so and then if I would have asked like for a different insurance uh, claim, it would have provided me with a different adaptive card to input different information, and the way that it's going now to process, it's going to ask me different information specific to that particular insurance claim. And then I have like a admin agent where I'm just giving it all the knowledge source it needs, but in that scenario, it's quite simple. It's just used like for reporting, and it's mainly like that's again another scenario because in terms of authentication sharing, this one would be more like for internal users rather than for the end users directly to be able to use that particular agent. So let's see whether the other one, this one is going to work. Yes or no. So I have like the insurance orchestrator agent, and I'm just gonna ask it. I'm just gonna ask it to generate a report for for claims which the insurance company had for the last 6 months, and we'll see whether it's actually works. Did I pray enough to the demo god? But probably. Let's see. Because we do have a timeout as well if it doesn't respond within a certain period. Okay, I'm not going to waste more time really because that's not the aim for it. So I have it somewhere. Come on. All right. So this is the one which I did like today, but maybe like 2 hours ago after trying many times, and then finally it kind of did generate the report. Yeah, so it's just taking data from my SharePoint libraries, and kind of extract some insight based on the data I kind of grounded the agent with. So I managed like, to find some, like for example, high value claims, which probably you might want like much more interesting to find out more about it. And then of course, I'm gonna give it another try again, but if it doesn't, then I'll have to go with the tempo which I already listed before. The let's say amount and insurance code. Let's see. Oh, so that's one is kind of behaving. So again, like this is the it's kind of triggered like correctly the child agents, which is insurance code agent. And let's say I go for travel insurance, and it kind of started with topic within the insurance code agent, and then within the topic I kind of have like the adaptive card so that the end user could fill easily. So this is a for travel insurance code. So I'm just filling. It will be like kind of the details probably like if you're going on a holiday, you might want to get travel insurance. So you'll have like a similar kind of information that you need to provide. Say it kind of provide maybe the premium of yeah, based on the formula which I have. So yeah, so that's kind of my demo session about the connected versus child agent. I was kind of expecting like if I had was a bit lucky, it would work live, but we move on to Lee now.
Okay, all right. I'm just going to share my screen actually,
Hmm.
so I don't forget. Hopefully you can see it soon. We're good. We can see VS Code. That's always a good sign. So I will now take over. It's not letting me present full screen. There we go. Okay, so Agents Toolkit. So obviously, thanks for covering the Copilot Studio bit for us. So Agents Toolkit, we have two kind of distinct types of agents when it comes to multi-agent architecture. The left is declarative agents, so that is kind of the sort of low code stroke very small amount of code, declarative code, things like JSON files and YAML files. Um, and that gives us the ability to, even though the documentation here doesn't show other agents, it does support other agents. But the key difference here to a custom engine agent is that the orchestrator, the models, the user experience, that's all M365 Copilot that you already use. What we're doing there is just effectively adding some instructions to the agent in addition to what you would get with the out of the box M365 Copilot. And then on the right hand side is custom engine agents, and that's where the only thing really that makes it Copilot, truly speaking, is the user experience. It's where it's accessible. So in this case, it's accessible in Teams as well as M365 Copilot, but the orchestrator, the foundation models, the skills, everything, the connected agents, that's up to you. You can choose whatever you want. So you might already have an agent that you've built that you're using, nothing to do with Copilot. You want to bring it into Copilot, or you can do that using that method. As far as multi-agent goes, there's kind of just a key point here that when we're talking about declarative agents, we can only call other declarative agents. What we can't do is we can't call, say, a Copilot Studio agent or something like that. Whereas with custom engine agents, because it's effectively code, we can call all different types of agents. We call Foundry agents, Copilot Studio agents, other agents using agent-to-agent protocol. So that's kind of a key differentiator between the two. So here's a pattern of something that I'm going to demo in a minute, where we have effectively three agents. We have the orchestrator agent in quotes, and the reason it's because there's no real definition when it's your own code. You can call it whatever you want. So in my scenario, the orchestrator agent's the main agent. So users using M365 Copilot talk to that. And then off to the sides, we've got a ticketing agent and a knowledge base agent. So this scenario here is where we're trying to ask for help. So in this case, the orchestrator agent has a LangChain orchestrator. It's then talking to the Foundry agent on the right-hand side, which has its sort of own orchestrator, but we don't get to control what that is. I don't know what it is, so I've just put non-applicable. And that has some index documents, which are the knowledge base articles. And we have exposed a tool called Find KB tool. So when we're talking about tools and skills and actions and plugins, they are kind of all used interchangeably sometimes. In our case, when we're talking about a tool, it's like an action to do something. So in this case, it's Find KB, right? Find the knowledge base article on the particular issue that the user's having. So let's say we can't solve the issue. We've gone through the knowledge base articles and we're able to resolve it. On the right, on the left-hand side, we then have another agent. This time we're using an agent-to-agent protocol to call between the two, and that's connecting to a database, and that allows us to create tickets and also update tickets, but also retrieve tickets. And all of this is done through the central orchestrator agent. So we'll get into the demos now. I'm going to quickly show you the declarative one because that's I've already kind of run it 5 minutes ago, just to kind of show you how it all works. It's a very straightforward one. So effectively, what I'm asking here is, what do I have on today? And what it's doing is it's connected to the Jira agent, so the built-in Microsoft published Jira agent, not one that I've created. The planner agent, which is a frontier agent at the moment. And effectively, it's calling those two other declarative agents, because all the agents that are published in the agents catalog are declarative agents. It's then also looking at my meetings and my emails, and it can see here that there's a meeting that's obviously going in. We're on it now, and obviously I had a previous call earlier on this morning, and then it's gone through my Jira, it's gone through my planner, through my emails, and then it's kind of given me a summary at the end, and that's all done via effectively a declarative agent talking to other declarative agents. So I'll just quickly show you how that's built. It's very straightforward. We have a declarative agent JSON file, standard things like names and descriptions. The instructions I'll get to in a second. And then this is where we add the ID of the agent. So one of these is Jira, one of these is Planner. So it's the ID of the agent. And then we've also added in the ability to bring in our emails and our meetings into that agent. That's the agent configuration. There's no way the hidden files, that's it. The only thing that we've added on is the instructions. And I've just said you're an agent that helps users work out what they have on the on their date for the daily tasks. I've asked it, check users calendar, check if they've got any emails that require attention, and then I've just labeled effectively what each agent is. So the Jira agent is this ID, the planner agent is this ID. So when it's looking, oh, let me check what's in Jira, it knows, oh, this is the one I should be calling, and obviously that maps to this ID in here. That's it. I literally hit publish, it appears in Copilot, and that's it. I would say that's probably simpler than Copilot Studio, but maybe that's me as a developer. Now, if we change to a custom engine agent, which is one I've got here, which is the one that I was just going through the architecture on. I've just got a typical IT help desk. I've got a problem. I need to log a case, or I need to retrieve, update a case or something like that. So I'm going to go down the road of I'm having an issue. Okay, now I've got to pray to the demo gods that this is actually going to work. This is running on my local machine currently, so if it does break, I can blame my machine. Obviously it's going to, before it does anything, it needs to know more about what is the actual issue, right? Now, I've added a debug card in here so we can actually see what's happening. So currently we're using the 5.4 mini model for the orchestrator. So now if I say, I have an issue printing, I click print and it does nothing. Okay. Okay, so now it should hopefully go off and find something about printing from the knowledge base in the Foundry agent, which is connected to this agent. Okay, it's come back with a load of stuff. All right, so it's found knowledge base article 9. And it's going to go through, if you check this, if you, is the service running, blah, 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 blah. Okay, now I'm going to pretend that I've done all these 9 steps and it still doesn't work. Now, before we do that, we can see here, it's found the Find KB tool and it's decided that's the tool it's going to use to find a knowledge base article. So then it's talked to the Foundry agent. That one's using a different AI model because we don't have to use all the same, or we don't have to be limited to GPT or Claude. We can use any model that's in Foundry in this scenario. Now it's found a knowledge article and it's returned back the sort of unformed or very basic instructions, and then what we've done is we've kind of like fleshed them out to a bit more detail. Now if I say I've tried this and it's still not working. Okay, now hopefully it's going to offer to raise a case for me. It's thinking about it anyway. So what should happen here is in the background whilst it's doing it is it all goes back, always goes back via the orchestrator agent. In this case, the orchestrator agent saying, oh, I need to raise a case for this. So then I'm going to go and talk to the create case tool that's connected to a different agent, using the agent to agent protocol. So in this case, it's gone through and it's created a summary and it says, I've created a ticket for you. And then I've got an adaptive card here that I've created with the ticket information in, and it's decided what priority and category, and it's kind of outlined what I've done. So user has reported clicking print, nothing happens. They've already performed all the troubleshooting steps, blah, 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 blah. And here's some suggested steps to sort of go on from there. Now I can see I've called a different tool this time. I'm using a different model. I've never heard of it. It sounded different to GPT and Claude, so I thought let's just try a different model just to sort of demonstrate that you can choose whatever model you want. And it's using agent to agent to talk to that other agent. And again, we can see the request and the response. Now the response actually comes back as an object, JSON object. We then turn into an adaptive card to make it look a bit more pretty than just raw JSON file. So how does that work under the hood? I'm not going to go into a crazy amount of detail because there's lots of code and we don't have the time to do that. But effectively, we have a main agent file, and this is where we have things like the instructions, like we had in a declarative agent or in a Copilot Studio agent. We create the orchestrator agent here using a particular model. So that's where I can define what model I want to use. I can define what temperature to use. And then the agent tools, these are the tools that are available. So we've got 4 tools there. And what happens is when we create this orchestrator agent, it's then creating something called a LangChain sort of orchestration layer. So when we then get a message, we use this as the system message. We send this along with all the tools and everything to the agent, and then the agent decides if it needs to call any tools, whether it needs to obviously respond or not, and effectively we send the message back to the end user. I'm just going to quickly show you just another kind of child agent, I suppose. So here we've got a Foundry one. So in here we define the tool. We're using the same sort of tool schema that we use for all the tools, whether it's in Foundry or an agent-to-agent tool. Again, it's using LangChain, and effectively in here we are creating a client connection to Foundry, because that's where the agent is residing in this case. The agent doesn't run in this code; it runs in Foundry. We then effectively send this request up to Foundry. So the input is the query is the text that I've put into the conversation, and then effectively it's then making that call up to the Foundry agent. Foundry agents are then coming back with the information, and then we're returning that text that's come back from the Foundry agent. And then the last bit here, it is just a description of what the agent is, what it's there for, and this ends up being sort of fed back to the orchestrator agent. So when the orchestrator agent's looking to use what tool am I using, it's using this description as its determining factor to go, oh yeah, that I need to raise I need to look at a knowledge base article. Wow, this looks like it's probably the most likely tool to serve that purpose. It's not just using the name here to determine that. And I think that's it from a demo perspective. I think we've got a couple more slides, so I'm going to sort of present again. So just kind of, I kind of touched on earlier on, like what sort of the strengths of Agents Toolkit. I think key important thing here is when we're talking about multi-agent specifically is there's no real winner or one that's better than the other. I think it really does depend what you're looking to build, what you're comfortable using from a tooling perspective, also what you might already have. So if you already have an agent built in code that you want to just bring into Copilot Studio, into Copilot, then that's fine. If you've built something in Copilot Studio, like you've already got a sort of an agent that does something and you want to just connect to that existing agent, again, why would you build something in Agents Toolkit when you have that already? Sort of key differences, really. One is that you can connect to agents in the catalog, i.e. other declarative agents using Agents Toolkit. You can't do that with Copilot Studio. And when it comes to like developer insights, they are slightly different. So with Agents Toolkit, obviously you can either use when you're using a declarative agent, you can enable debugging and you can see the conversation the agents are having. And also with Copilot Studio, you can kind of see what the agent's doing, but what you can't necessarily see is what the agents are doing between each other, how they're communicating. You don't see that in the same way. Whereas, say, a custom engine agent, they're actually having a conversation like we would have. They're talking in natural language. And then the other thing to obviously kind of point out is that in Copilot Studio, you have to use the custom engine agents. You can't use declarative agents to do any connections, between agents. And then sort of the last slide really is that if we just ignore the multi agent approach and just look from a general perspective, which tool should I be using? We haven't really thought about multi-agent at this point. You're just like, I want to build an agent. Again, there's no clear winner really. I think it depends on which tool you're most comfortable with. If you're more into coding and you like VS Code and things like that, then probably Agents Toolkit is where you start. If you're more familiar with things like the Power Platform, probably want to start with Copilot Studio. There are differences when it comes to costs, like I alluded to earlier. There's less costs maybe building something in Agents Toolkit, but the key differentiator there is that you then have to host something yourself if it's not a declarative agent. Whereas if you put something in Copilot Studio, everything's hosted by Microsoft. You don't have to worry about spinning up Azure subscriptions or consuming models in Azure Foundry or whatever. It's like a fixed cost. It's hosted, and you can kind of use it as much as you want. I think the other kind of most important thing really there is the governance side of things. Copilot Studio has it built in because it's part of the Power Platform. Whereas if you're building something yourself, you will have to factor that in, or if you want that anyway, you'd have to add that into your own application and choose whatever tool you feel most comfortable using. And I think that's it, Reshmee, unless you've got any other thoughts on that. You're on mute.
I know.
Yeah.
Yeah, so the only thing is around like the M365 Agents Toolkit where it's actually being published. It's actually like in the Teams store. So Microsoft Teams store. So it used to be called like Teams Toolkit and it's more like an evolution to the M365 Agents Toolkit, but it's kind of still have where it's being published. It's still like the same and and how you're gonna govern the agents. It will be like from the team store, for example, if you want like to publish, make it available to the whole organization. If you want to delete it or do other things, it's a different platform completely. Yeah. Thank you very much for listening. I know it's been a very long day.
I think we have one question that I saw in the maybe more.
Q&A.
There are
So
multiple
one.
questions.
Oh, that's good. Okay, that's good.
No, it's only two, but it was multiple.
Yeah.
Okay, one is your demo in a public GitHub repo? And can you share it?
Yeah, it will be. I am just sort of kind of in the last stages of just testing it, but yes, I will publish it. And if you follow me on something like LinkedIn, I will whenever I do anything like this, I do publish it in GitHub, openly available for everyone to see, and I will publicize it on social media. So yeah, you can obviously download it and then use it in your own agents. Yeah.
Perfect. And the other question already got answered by Reshmee, right? Is SDKs in different languages, which is the most mature one to use? Same question for Microsoft 365 Agents SDK.
So when it comes to Agents SDK, I'll answer that one. It's available. You can build agents in mainly C# and TypeScript. I think you can maybe do Java, or Python.
I don't know about Java, Python probably.
Python, yeah.
Maybe C#.
Yeah, I think I've had
Okay.
most experience with TypeScript. I think, to be honest with you, I think they're all pretty robust. I think the only benefit that you get something like C# is that you can use the agents framework. So if you want to use things like semantic kernel, you'd have to use something like Python or C#. But I think largely they're all pretty mature, and like Reshmee said, they're based on products that have been around a lot longer than the name would suggest. So that there is, that they are pretty they're pretty mature at this point.
Right. Another question just coming in. Does it mean if we want to use multiple agents like independent ones, we need to be proficient in coding?
No,
No.
no, I don't think so. Yeah, no. So ultimately, I think the general output of the session is that you can build agents in something like Copilot Studio. So if you're more comfortable with building things that way, in Power Platform and using UI tools, then yeah, you can build multi-agents that way. You don't need to code anything. But if you want to use code and build something completely from scratch to do exactly what you want it to do, then yeah, Agents Toolkit and Agents SDK is probably where you want to go.
Well, anything I would say, like, for example, if you use Copilot Studio, you're a little bit kind of restricted. Like, for example, the orchestrator or the models, you can't really change it. But if you use like something, a more pro-code approach like Lee showed, like a custom engine, then you have a little bit more choice in terms of the model that you're going to use and as well as the orchestrator. And you might end up like with different output, because each time like Microsoft even like change like the underlying language in the Copilot chat, like the experience that you get is quite different, even like if you have like the same agent. So if you have a custom engine, you have a little bit more control and like that model that you kind of decided when you designed it, that will be still be in place. So it's kind of yeah, I would say like it depends like how much control you want over the whole platform. And if Copilot Studio is sufficient for your particular scenario, then yes, go for Copilot Studio.